We know with alternating signs, whenever you do that, you're going to do -1 in parentheses, and then you have to do it to a power of n. Okay. So this is what alternates signs. When you do a -1, you could have a -1 to the n plus 1, a -1 to the n minus 1. This one, we're actually going to do a -1 to the n. Okay? And I'll talk about how we know which one to do. So if we do this -1 to the n plus 1, if we start with our first term, okay, term number 1, that means we're going to have -1 to the 1 plus 1, right? Which should be 2, okay? So that would this be a positive or a -1? What is the second power? Positive, right? Because it's something squared. You might not be putting in parentheses, would be my guess. This would be -1 squared, right, for our first term, which would make it a positive, right? Okay. So if it's an n plus 1, you get a positive, right? So this will give you a positive first term. Okay. Let's try the n minus 1. Same thing. So -1 to the 1 minus 1. That's -1 to the 0 power. That's 1 as well, right? Positive 1. Okay. Anything with 0 power is 1. Okay. So that's a positive 1 as well. Now this one, -1 to the n. Let's try that. -1 to the just whatever the n is. So first term would just be 1. What's -1 to the first power? -1, right? So this will give you a negative first term. That's all you really have to worry about, because then it'll alternate after that. So if we want a negative first term, then we want to use this. -1 to the n. The ones that we saw yesterday always started with a positive. And so it was either n plus 1 or n minus 1. It doesn't matter which one you use. But these two will alternate and give you positives. This will alternate and give you a negative. Does that make sense why that works? Okay. So that's going to be our first part. This alternates it, so our first one will be negative, our second one's positive, third one's negative, fourth one's positive. So this is our alternating part. Next, let's just look at, let's say the first one. Okay, the 1 is the same as the n, right? 1 and 1, 2 and 2, 3 and 3, 4 and 4. So the top number is just n. So it's going to be times a fraction n over, how do we get the bottom number? How do we get 2 for our first term? How do we get 3? Yeah, you just add 1 to n, right? So it's n over n plus 1. So the top number is whatever term it is. And like I said yesterday, it's helpful to write the number of the term over top of it, because then you can see it just lines up. So all these, it's just n on the top. On the bottom, it's just whatever n is. You just add 1, add 1, add 1, add 1. So this is our... Definitely is the hardest part about doing this, though. Don't get discouraged if you're not good at that. All right, so with that in mind, I did want to go over a couple of the homework problems, specifically where you had to write these sequences. So I was going to do the ones where you have to write them, and if you want to see any of the other ones where you have to write out like you have to write out the term, just let me know, and I'll be happy to do any of those too. But I was definitely going to do... well, I could just do all of the ones where you have to write them, just to make sure you got that. All right, so number 30, it was this 1 over 1 times 2, 1 over 2 times 3, 1 over 3 times 4, some more. That was the pattern. So we would say a sub n equals, let me just get rid of this part. What does it equal? So 1's always the same. Yep. This is our first term, our second term, our third term. Notice that number's here. So that's n. Okay. So n times, and then this number is always 1 more, right? So yeah, n times n plus 1. And you can do the curly brackets even better. So that's the first one. Number 32. Yeah, this one we got 2/3, 4 9ths, 8 27ths. So first term, second term, third term. So we have our a sub n equals right, so let's think about our tops. Okay, we get 2, 4, 8. So what are those increasing by? Well, like a factor of 2 each time, right? Times 2, right? Because 2 times 2 is 4, times 2 is 8. Next one's, I think it says 16. Yeah, it says next one's 16, then 81. All right, so the top is factors of 2, right? Yeah. So it's going to be 2, this is 2 to the first power, 2 to the second power, 2 to the third power, 2 to the fourth. So we say 2 to the n. Yeah, and then the bottom is powers of 3. 3 to the first, 3 to the second, 3 to the third, 3 to the fourth. So 2 to the n over 3 to the n. I know it's kind of hard to just come up with that out of thin air, right? But just take some practice. All right, so 34th. So this one was the most challenging by far. I'll never give you one like this on a quiz or a test where you got to figure this one out unless it was a bonus. Okay, now this one's kind of unique because it doesn't alternate signs. It alternates like a whole number, fraction, whole number, fraction, whole number, fraction, right? So it's kind of a different alternating here. So this one, well, you'll notice the pattern is such that our first term has a 1, second term is a 1/2, so the 2 is in the bottom, third one's a 3, fourth one, it just takes the 4 to the bottom, 5 is 5, 6. So you can see there's definitely something going on here. All right, so the question is, how do we get something to the bottom of the fraction generally? Like, what would make this 2 go to the bottom or make this 4 go to the bottom? How about if it was an x, all right? So what if I had like x versus 1 over x? What makes that go to the bottom? We had division, but what makes me take it to the bottom? Yeah, a negative exponent, right, yeah. A negative exponent takes it to the bottom, okay. So we can do the same with numbers. If this 2 had a negative exponent, if this was 2 to the negative 1, then it would go to the bottom, right? And if this 4 had a negative 1, then it would go to the bottom. So we want to somehow figure out how to make this a positive exponent, and then this a negative exponent, and then this a positive, and this a negative. So let's start with n, because n is definitely the number that's going in there, right? And it's going to be n to some exponent. Well, how do you alternate, the signs? We do our sign alternating, which is -1 to the n plus 1. And it's kind of crazy because it's like a double power. And it's kind of, I guess, trippy, you could say, I guess. I don't know if that's what to describe it, right? You got a power raised to another power. So let's just kind of try this and see what happens. So my first term is going to be 1 to the -1 to the 1 plus 1. Okay. If I try my first term. So this is 1 to the -1 squared, which is positive 1, right? So 1 to the positive 1, which is 1. Okay, so it works for the first term. So let's try 2. 2 to the -1 to the 2 plus 1. So this is 2 to the -1 to the third. Well, -1 to the third is a -1, right? So 2 to the -1, 2 to the -1 is the same thing as 1/2. So this will alternate flipping it as a fraction. So this, like I said, is a really hard one. I'm not going to make you do one that hard on any sort of assessment. But it's kind of a neat one to try, where you have a power raised to another power. Maybe it's just cool if you like math, your math teachers. Anybody else thinks that's neat? Okay. All right, 36. So this last one we had 2, -4, 6, -8. All right. So what's happening here is alternating signs. Definitely. So that's going to be -1. The first one is positive, right? So we're going to go with, we can do an n-1 or an n+1, either or. -1 to n plus 1, that will make it alternate. And then each one is just, if this is our first term, second, third, fourth, just being multiplied by 2, right? 2 2 times 1 is 2, 2 times 2 is 4, 3 times 2 is 6. So it's just an n2n. Negative 1 n plus 1. Huh? Did you forget the parentheses? Alright, so those are the hard ones. It's a good brain challenging problems. Today we're going to keep looking at sequences. It's going to take a few minutes here. But we're going to look at a different type of sequence. It's going to look mostly the same to you. One minor difference here. Has anybody seen this before? Know what this is called? 5 what? What's the? Is it just 5? You just say like 5. 5. Is that what you say?
That would spin.
What is? You just yell 5 when you see that because it has an exclamation mark. What do you do? Huh? Is that what you do?
You do 5 times 4 times 3 times 2 times.
Okay, yeah, that's right. Yeah. So this, nobody knows what it's called. Yeah. This is called a factorial. You use these a lot in probability and statistics. If you take, there's some fair amount of juniors in here. Yeah, so if you take math next year, chances are it'll be prob and stats. Probability and statistics, there'll be like a normal version, and then we're going to have a CCP version next year. So either one, you'll see this factorial symbol in probability and statistics. Used a lot in probability. Okay, and so the reason why I brought this up is this factorial symbol is kind of neat because it's actually like a sequence. So this 5 factorial, 5 exclamation mark, what it means is 5 times 4 times 3 times 2 times 1. Okay. If it was 100 factorial, you would do 100 times 99 times 98 times 97 times 96 times 95. Go all the way to 1. So kind of how this works then is you essentially have some starting value, we could say n, and the next one is n minus 1, right? And then the next one is sort of n minus 2, right? N minus 3 kind of just goes on forever like that. So what's kind of unique about this sequence is the next number in the sequence depends on the previous number. Okay? So if we just took a random spot inside of here, say I didn't know what this number was, if I just said this position right here, what's the number? Well, I could find that by just looking at the previous number, right? That would tell me what that number is going to be. So this is called, this is kind of illustrating what's called a recursive sequence. So it's a sequence where the next number in the sequence depends on the previous number. So we can't get the next one unless we know the one that came before it. And there's another really cool illustration, which I might have you do something on tomorrow, called the Fibonacci sequence. You've ever heard of that before?
That's the one where you multiply the number of the last number.
No, you don't multiply it, but I'm not going to tell you what it is just yet, because I think I'm going to have a video maybe tomorrow. But it's a pretty cool thing, Fibonacci sequence, and but it's a recursive sequence. And so there'll be, like I said, I think there's going to be a video which you have to do in learning tomorrow, virtual learning, where I talk about that. But that is kind of an example of called a recursive sequence. So recursive sequence is still a sequence like we've seen, except in this one, each term depends on the previous term. Okay? So it's just another way of defining a sequence, but each term depends on whatever the previous term was. It's called a recursive sequence. You can kind of think of it as like reoccurring. So the next term you sort of have to, is the previous term reoccurring. And there's lots of different types of sequences. We'll see some more in the next section, arithmetic and geometric sequences, and summations. So there's a lot of different types of these. They all have the same idea, just we kind of define them a bit differently. All right, so there's some notation I want to show you with this one. if you're going to do a recursive sequence, like if we look at the factorial symbol, well, with a factorial, how do I know where to start in the factorial? Let's say I have 8 factorial. How do I know where to start? What number do I start with? 8. Obviously 8, right? Yeah, so we start with the number that's here. So this 8 is what we're going to call our first term. We're going to call that a sub 1. Okay. So when we have a sequence, you can number it based on this is the first term, second term, third term, based off of the subscript. So the first thing in our notation is we always have to be given a starting spot. Okay, so a sub 1, when you do this, this is going to be your starting number. If you're given a sequence, you need to know which number to start with. So a sub 1 is going to be our first term, our starting number. Okay, and then we're going to have a sub n like we had before. That's just kind of like our current term. You would think like our, what's that one? Current term we're trying to find. You could say the nth term is another way of saying this. And then one more that we're going to see, so you've really kind of seen these already, is a sub n minus 1. So the minus 1 is down there in the subscript as well. Anybody think they know what that would mean? A sub n minus 1? If a sub n is our current term, what would it be?
Whatever number proceeds after that.
Proceeds before it, yeah.
Before it, yeah.
Yeah. Right, yeah. So we can call it our previous term. Because if this is a recursive sequence, it depends on the previous term, but we need to know what that previous term is. The thing is, we'll always be given a starting term, because we can't just start from nothing if we don't have like a prior term to start with, right? You can't just start. You don't know where to start if you don't have a starting number. So then our second term will be whatever the starting number is, and then whatever operation we're going to add on to that. So these are important notations here. We're going to be looking at some problems on delta math to do this. They've got some good practice on there. So we're going to flip to there, but don't start working on them just yet. I want to look at those together, but these are going to be the notation that you'll see on delta math. So a sub 1 is whatever you're starting with. You're going to be given a formula here, a sub n, and then this a sub n minus 1 refers to the previous term. Okay. All right, so I'm going to flip to that. It's got some good problems. So there's some different levels here. I'm going to have you just kind of work your way up, just 2 in each one of these, and then some other ones here. Well, let's try this first one. All right, so it's going to ask you to find the specific term. So here it gives us an a sub 1. It tells us our starting point is 2. Right? Then it says a sub n, which we just talked about. This is kind of how we find our next term, our current term. And we're asked to find a sub 6. Okay. So we're just going to type in the answer to a sub 6. So this is how it works. We're going to start with a sub 1. Okay, that's 2. Now let's try, this is a sub 1. Let's try a sub 2. Okay. So a sub 2, our second term, using this formula here, if you want to write it down again. So if you want to write down a sub 1 is 2, a sub n equals negative 2, times a sub n minus 1, negative 2 times a sub n minus 1. So this is what we're given, and we're asked to find a sub 6. Well, in order to get a sub 6, we can't just jump to a sub 6, because we gotta work our way up, right? Each term depends on the previous one. Okay. So let's start with a sub 2. Well, here's our formula. Our formula says we just do negative 2 times the previous term. Because remember, a sub n minus 1 just means previous term. So we just do negative 2 times the previous term. Well, our previous term is a sub 1. Okay, so it's 2. So negative 2 times 2, so it's negative 4. Make sense? Okay, so we took our answer to our previous one, and then we write that. Okay. Then a sub 3 is going to be negative 2 times what? Negative 4, yeah, our answer to our previous term. So that is positive 8, right? So then a sub 4 is going to be negative 2 times our previous term, 8, right? So that's negative 16. Then we do a sub 5. Negative 2 times our previous term of negative 16. Positive 32. A sub 6, which is what we're asked to find. Negative 2 times a sub 5, which is 32. So it's a negative 64. So if we were to write this out as a sequence, it would look like this. Negative 4, positive 8, negative 16, positive 32, negative 64. On Delta Math, I'm not going to have you type or write out everything, but you have to do it in order to get to this term, right? So then you would just type in negative 64. That would be the value of this term. Okay. So each term depends on your answer for the previous one. All right, so that's the easiest level. So let's try the next one. And all of these are very similar. It's just maybe an extra operation in each one. It's going to work the way up. All right, so I'll write out the next one. We've got a sub 1 is 1. We've got a sub n equals negative 5 times a sub n minus 1 minus 4. So the same thing as before. All this reads is negative 5 times the previous term. So whenever you see this a sub n minus 1, say previous term. Negative 5 times the previous term minus 4. Okay? So let's start with a sub 2. That's always going to be our first term we find. It's going to be negative 5 times previous term is 1 minus 4. That little operation there. Negative 5 minus 4, negative 9. So that's our answer. That's going to get plugged into the next one. So we're asked to just find a sub 3 on this one, so we don't even have to go as far. A sub 3 is going to be, well, take our formula, negative 5 times previous term, negative 9, minus 4. So this number here comes from here. This number. So that's 40, positive 45 minus 4, so 41. That's our a sub 3. And if this was written out as a sequence, it would be 1, negative 9, 41. Get the hang of it? Okay, let's try next level. So for this one, we've got a sub 1 is 1, a sub n is negative 2 times a sub n minus 1 minus n. So it's just a bit different here. It's got an n in there as a constant. So we'll find a sub 2 to start, because it gave us a sub 1. A sub 2 is negative 2 times previous term. We said it's in previous term. Previous term is 1 minus, what is n? What's n here? It's not previous term. This is the previous term was 1. It's 2, yeah, it's this number. So it would be negative 2 minus 2, which is negative 4. So that's our answer. And then a sub 3 is going to be negative 2 times our previous term, negative 4, minus, now it's not 2 because it's changing. This is it's n. So whatever this number is, it'll match this number. That's n. So that's going to be positive 8 minus 3, so that would be 5. And then we do a sub 4, which is negative 2 times our previous answer, which is 5, minus 4, because that 4 is going to match you. So that's negative 10 minus 4 is negative 14. And then ask us to find a sub 5. So a sub 5 is negative 2 times previous term, negative 14, minus 5. 5 is in. So that's 28 minus 5, 23. So that would be it. And again, if we were to write this out as a sequence, it would then be 1, negative 4, 5, negative 14, 23 would be next. Just a different way of going about finding that. And then I think there's one more. I might actually get rid of this sequence one because it makes things just a bit more confusing. And as you find a sub n plus 1, but it works the same way. And then there's a few, we have to write the formula. But I'll probably actually eliminate that one there. So then you have to write a formula. Given this, you have to type in a couple things. First, it asks you for a sub 1. So that's just going to be the first term here, which is 4. And then you have to write a formula for a sub n. So you just figure out, well, what's happening as you go from this to this, and then from this to this. What happens there? By negative 6, right? 4 times negative 6 is negative 24. And negative 6 is that. So our formula then is negative 6, and then times the previous term. Right, so you just hit a sub n minus 1. So negative 6 times previous term, that's going to be your answer. I think most of them are pretty easy to figure out. This one you can see is just multiplying by 4, right? 5, 20, 80. So you just do a sub 1 is 5, and then a sub n is 4 times a sub n minus 1. Okay. And then the last one, you have to choose the correct one. So you find the right starting value. These all start with 5. You got to find the formula that matches this. So just basically plug it in. Is it going to be negative 4 times 5 plus 3? You get 3 times 5 plus 3 to get that. So you just got to choose that one. Okay, so you've got the rest of the period to work through that. If you're stuck on any section, let me know. I am going to eliminate that level 4. Just I don't want to confuse you too much, so make it just a little bit shorter. So go ahead and work on that. Again, let me know if you need some help understanding it.